Today we're going to talk about logarithms. So what is a logarithm? So we've talked about exponential functions, and a logarithm is the inverse of an exponential function. So by definition, you can see here, a logarithm is another way of writing an exponent. So if you have log base b of a equals x, then you also have b to the x equals a. So you can see that you go from b to this power equals this. So we're going to use that in order to just rewrite these as exponential form. And later you'll see why we do that. But logarithmic form is the inverse of exponential, and therefore we can use this in each case to rewrite it. All right, so write each equation in exponential form. So we're going to say 3 to this power equals this. And this should make sense because 3 squared equals 9. Okay? All right, here we're going to say 6 to the third equals 216. So 6 to the third equals 216. And down here we've got 7 to the 0 power equals 1. And if you remember properties of exponents, anything to the 0 power equals 1. And here we've got 2 to the 4th equals 16. All right, moving on to the next examples. Here we've got 4 to the negative 2. My pen got big for some reason, equals 1/16. So 4 to the negative 2 power equals 1 over 16. Again, this should make sense because a negative exponent means you move it to the bottom. Again, that's properties of exponents. Now we've got 9 to the 3 halves. 9 to the 3 halves power equals 27. So this is just using the little rule that we said at the beginning, where if you have b to the x power equals a. All right, now we're going to go to logarithmic form. We're going to go in reverse. Okay, so again, we had, if you look back at the top of your notes, you had log base b of a equals x, and that means that b of x equals a. So we just took this and converted it to this form. Now we're going to do the reverse. We're going to go from this form back to this form. So we're given exponential form. How do we know? Because we've got b to a power equals a. So b to the x equals a. And we want to write it in logarithmic form. Okay? So we're still going to do the same thing as we did before. So we're going to go from b to a back to x. So 14, that's our base, that's our b. So we're going to have log base b. B is our big number, our base here. It's going to be the little number here at the bottom. Base is the small number. I'm trying to make it small here. It's kind of hard with this pen. Let's see. 14, and then a is the number over here, 196, equals our exponent. So all we're doing is using this at the top of your paper here. I rewrote it here, but you can go from one form back and forth. So what we did was, in the beginning, we went from logarithmic to exponential. Now we're going from exponential back to logarithmic. So log base 3 of 81 equals 4. Here we've got log base 12 of 12 equals 1. And you're going to see anytime these numbers match, that's going to equal to 1. Here we're going to have log base 36 of 6 equals 1/2. All right, just a couple more examples here. Log base is 2 of 1/8 equals -3. And the last example here, again, we're going from base to this number back. So we're going from log base 8 of 16 equals 4/3. So if you just kind of remember that pattern, that you can see how this works. All right, make sure you've got these down, and then we're going to move on to base 10. All right, now we're going to talk about something called a common logarithm. This is a logarithm which has a base 10. If you see a logarithm that's written just log of x, and there's no base, that represents your common logarithm. So if it doesn't have a base and it's written log of x, then that's the same as base 10. That's similar to having an x without a variable in front of it, or a square root without an index of 2 to represent square root. So if you have just an x, that equals 1x. If you have a square root, that equals the square root. And if you have log of x, that equals log base 10 of x. So this is called our common logarithm. This is just something that you have to, just kind of memorize, get familiar with. If there's no base, that means base 10. Okay? All right, so how do you evaluate a logarithm? Well, there's several ways to do that, but the easier ones, like these, you're going to say, okay, logarithm was base to x equals 49. So what is that power? So if we have 7 to some power equals 49, we just have to say what power would make that 49. 7 squared equals 49. So you just have to have a good number sense, have to be familiar with your perfect squares and things of that nature. So basically what we're doing is saying log base 7 of 49 equals what? And we're saying like it's missing this number here. So 3 to some power x equals 27. So what power of 3 is 27? Well, that would be the third power. So x equals 3. 3 to the third power is 27. All right, number 15 doesn't have a base. Remember, if it doesn't have a base, that's base 10. Okay, that's our common logarithm. So we're going to have 10 to some power, because we don't know what this is, equals 100. So 10 to what power equals 100? Well, 10 squared. So x would be 2 in this case. All right, for number 16, we're going to have log base 12 of 1 equals x, and it's important that you get familiar with the terminology here too, like reading these log base 12 of 1 equals x. That's kind of the proper way to read these. And then you're going to say 12 to what power equals 1? Well, anything to the 0 power equals 1. That's properties of exponents. Anything to the 0 power equals 1. All right, moving on down to 17. So we're going to have 2 to some power equals 64. If you are not familiar with your powers, then you may have to look at your powers. But 2 to some power, I'm going to play with that. I know 2 to the 5th power is 32, so this is 2 to the 6th power. And then this one's going to be 3 to some power equals 243. And if I play with that, I'm going to say I know that x equals 5. 3 to the 5th power equals 243. So 3 squared is 9. And then 3 to the 3rd is 27, 3 to the 4th is 64, and so on and so on. So make sure that you are aware of your powers. And again, you may have to get a chart and play with these for a while until they get more familiar. I'm going to have 9 to some power x is going to equal 1 over 81. Well, I know since this is a fraction, the 81's on the bottom. I know 9 squared is 81, but I know that has to be a negative exponent. Again, being familiar with your properties of exponents also helps. Knowing that that's on the bottom tells me that that's negative 2. So 9 to the negative 2 power equals 1 over 81. And then the last example of these is going to be 64 to some power is going to equal 4. So 64 to the 1/3 power. Okay. Because 4 times 4 is 16, times 4 again is 64, and because we're going from a larger number to a smaller number, I know that's got to be a fraction. So you just kind of got to play with numbers there to see how that works. And you can check these by taking your calculator and doing 64 raised to the 1/3 power. That's an exponent. So 64 to the 1/3 power equals 4. All right, using the change of base formula. So this will change it to base 10, which is our common logarithm. And you can do this with any logarithm. So not all logarithms are perfect squares or perfect cubes or whatever. So if you say 16 to what power equals 64, that's not an exact number that you're just going to be able to look at and get. So you can change this to log A over log B. And that's how you use your change of base formula. So for number 21, this would be log. All right, so log of 64 over log of 16. So we're using this formula up here to do that. And then you can just type that in your calculator. Down the left-hand side, you're going to see a log button, and you can use that button to type this in your calculator, and it's going to give you 1.5. And this one's going to be log of 32 over log of 8. And if you plug that in your calculator, you're going to get about 1.6. Now you can use this even in the last section, but hopefully you have some kind of number sense and you can see that sometimes it's easier just to know the answers, especially for the ACT when it's a timed test. All right, 23, so I've got log of 54 over log of 2. Type that in my calculator, and I'm going to get 5.7549. And this one says log base 10 of 294, so I'm going to have log of 294 over log of 10. And when I type that in, I'm going to get about 2.468. All right, just a couple more examples here. So we're going to have log of 136 over log of 4. Type that in my calculator, and I'm going to get 3.5437. And usually on these, it'll tell you how much to round it. I'm rounding these kind of different amounts, but most of the assignments will tell you round to 3 or 4 decimal places, and just make sure you read that. So this is log of 136 over log of 6. Type that in, and that's going to be -2. All right, so that's introduction to logarithms. It's not very hard, just something new that you haven't seen before. And if you use the properties and the definitions above, hopefully it won't be too bad. If you have any questions, let me know.